A homologous series is a group of organic compounds that have similar structural features and chemical properties because they share the same functional group and have a recurring pattern of carbon atoms in their molecular structure. These compounds exhibit a gradual change in physical and chemical properties as the number of carbon atoms increases. The term homologous comes from the Greek word homos, meaning same, and logos, meaning relation or proportion. The key characteristics of a homologous series include 1. Functional group. All compounds in a homologous series have the same functional group, which is a specific arrangement of atoms that determines the chemical reactivity of the molecule. For example, in the alkanes, the functional group is the single carbon-carbon bond, CC, while in alcohols, it is the hydroxyl group DO. 2. Gradual change. Properties such as boiling point, melting point, density, and solubility exhibit a gradual change with increasing molecular size or carbon chain length within the series. This is due to the increase in London dispersion forces as the size of the molecules increases. 3. General formula. Each member of the series can be represented by a general formula, which shows the relationship between the number of carbon atoms and other atoms or functional groups in the molecule. 4. Isomerism. Isomers are compounds that have the same molecular formula but different structural arrangements. Within a homologous series, different isomers may exist, leading to variations in physical and chemical properties. Let's consider the homologous series of alkanes as an example. Alkanes, general formula, CH. Functional group, single carbon-carbon bonds is CC. The first member of the series is methane CH, which consists of a single carbon atom bonded to 4 hydrogen atoms. As we move down the series, each subsequent member differs by a CH unit. For example, 1.ethane CH consists of 2 carbon atoms bonded together with 6 hydrogen atoms. 2. Propane CH contains 3 carbon atoms bonded together with 8 hydrogen atoms. 3. Butane CH features 4 carbon atoms bonded together with 10 hydrogen atoms. This pattern continues indefinitely, with each subsequent member having 1 additional CH unit compared to the previous member. The physical and chemical properties of alkanes within the series demonstrate a gradual change as the number of carbon atoms increases. For instance, the boiling point and melting point generally increase with increasing molecular size, due to the increase in London dispersion forces which result from larger, more complex molecular structures. Isomerism is also observed within the alkane series. For instance, butane has 2 isomers, N-butane, normal butane, and isobutane 2-methylpropane. These isomers have different structural arrangements, leading to variations in their physical properties, such as boiling and melting points.